Hello, today's video is about adding and subtracting rational expressions. So when we add and subtract rational expressions, these are the steps we're going to follow, but we will come back to these in a minute. You can write them down if you want. First, I want us to recall fractions. So we talked about this in the last video some, but there's a difference in like bases and unlike bases whenever we add and subtract fractions, because fractions have to have a common denominator in order to add or subtract them. So let's see, we have 7/4 plus 3/4. When we have like bases, we add the tops or bottoms, add or subtract the top. So 7 plus 3 is 10, and we keep the denominator the same. So then when we reduce this, we're going to get 5/2. Then whenever we subtract, it's the same idea. 7 minus 3 is 4 over 4, which equals 1. Okay, so what about if we have unlike bases? If we have unlike bases, we have to convert these to the same thing, and we do that by finding the least common multiple. And the easiest way to do that, in my opinion, is to take the largest number, so 6, and list its multiples until you find one that's divisible by the other one. Okay, so we want to find a multiple of 6 that's divisible by 4. So 6 times 1 is 6. 6 times 2 is 12. Hold up, 12 is divisible by 4. That's as far as we have to go. So the question now becomes, what do we do to 4 to turn it into 12? We have to multiply by 3. Well, if we do it to the bottom, we have to do it to the top. And then what do we do to 6 to turn it into 12? Multiply by 2. We have to do that to the top as well. So this problem is going to become 9 over 12 plus 14 over 12, which we know how to add from the last section. We're going to get 23 over 12. And I use the same fractions in this one as well, so we're going to still multiply by 3 and multiply by 2. So we'll get 9/12 minus 14/12. And that is going to give us 9 minus 14 would be -5 over 12. All right, so we've refreshed our memory on fractions a little bit. Okay, I got cut off there for a second. So we're going to add or subtract across the top and keep the bottoms the same because we have like bases. All right, so that means this is going to be equal to 13a plus 5a all over 4a squared. 13a plus 5a is 18a over 4a squared. And then we're just going to simplify, which is what we did in our last assignment. So we're going to get 9 over 2a. All right, so again, we have like bases. So we get to just add or subtract across the top and then keep the bottom the same. So I'm going to look for like terms. We've got y squared here. This is just a plain y, and then we have a constant. So y squared, and then 8 plus 2 is 10, so 10y plus 21, all divided by y squared minus 9. Now, in order to simplify, we have to factor. You should remember this from the last assignment. So on the top, we're going to get y plus 7 times y plus 3, all divided by y plus 3 times y minus 3. And then as you can see, the y plus 3's will cancel, and we're left with y plus 7 over y minus 3. Okay, after this, we're going to do unlike bases, but let's do this one real quick. It is subtraction, so that's a little bit different. Let's make sure that we understand how this is going to work. So we have n squared plus 3n minus 7 minus all of n plus 1. We have to distribute this negative between every term on the second side, okay? And then we have n squared plus n minus 6. So then the top is going to look like n squared plus 3n minus 7 minus n minus 1 over n squared plus n minus 6. So then the numerator again reduces to, or simplifies to, n squared plus 2n minus 8, all divided by n squared plus n minus 6. And now is where we need to factor these two expressions. So the top will give us n plus 4 times n minus 2, and the bottom will give us n plus 3 times n minus 2. And we will cancel the n minus 2's, and that leaves us with n plus 4 over n plus 3. Okay, so now is when we are going to get into unlike bases, which are the little bit more difficult problems. And we're going to start by finding, because these have to have a common denominator. So we want to find the least common denominator. Well, I'll write that somewhere else. And we're going to call this the LCD. And the way that we do that is we find the least common multiple of 2 and 3. So remember, if we take the biggest one and list the multiples, 3, then 6, then 9. Well, 6 is the smallest one that 2 also goes into. So from the coefficients, we choose 6. And then the x values, this is going to make more sense in future problems, but you always choose the largest exponent of that base, or of that variable. So in this case, it's just 1, so we'll just have an x to the first. So our LCD is 6x. So what we want to ask ourselves is, what do we multiply? Here, we'll write it like this. 15 over 2x times something minus 16 over 3x times something. So, what do we need to multiply 2x by to get 6x? We can multiply by 3. So we have to multiply the top and the bottom by 3. And as you can see, 3 over 3 is just equal to 1. So we're multiplying by some special version of 1 to manipulate this fraction to look like what we need. All right, so on the right side, 3x to 6x, we would need to multiply by 2. So we're going to multiply top and bottom by 2. So then the next step is going to look like this. It's going to be 45 over 6x minus 32 over 6x. So then we have like bases now, so we keep the base the same, and we have 45 minus 32 on top. 45 minus 32 equals 13, and 13 over 6x does not reduce. So that's your answer for number 7. Okay, so what if our denominators are not monomials? What if they have more than one term? First, we have to factor them. So I'm not going to factor the tops. You don't want to deal with that because you're just going to have to combine them later. But we do want to factor both of the bottoms. So 5k minus 10 can be written as 5 times k minus 2. And then k minus 2 is already factored. So when we do the LCD, we are going to find the least common multiple of coefficients. And for us, that would be 5, because this is a binomial. It's one whole unit. So the LCD of 5 and this imaginary 1 is just 5. Okay, then we want to do the least common multiple of variables. And we do that by choosing the highest exponent. And we don't have any variables by themselves, but then we do the binomial terms. And in this one, we have k minus 2 in common. So it has to be part of the LCD. All right, so this is our least common denominator. We want to look at k squared plus 16 over, I'm going to leave this separated, times something, minus 4 over k minus 2 times something. So what do we multiply 5k minus 2 by to get 5k minus 2? Just 1. We didn't have to use anything. All right, and then to get k minus 2 to equal our LCD, we have to multiply by 5. So this is going to be k squared plus 16, because it doesn't change. It's all going to be over 5 times k minus 2. And then we have negative 4 times 5. So we get minus 20. And then k squared plus 16 minus 20 is k squared minus 4 over 5 times k minus 2. And then we're going to factor the top. K plus 2 times k minus 2 over 5 times k minus 2. Cancel the k minus 2's, and we're left with k plus 2 over 5. And that is your final answer. All right, so let's look at number 11. For number 11, the first thing that we need to do is factor the denominators to make sure that we can look at all the different factors. So x plus 2 is its own binomial, and over here we're going to get x plus 3 times x plus 2. All right, so when we choose our least common denominator, when we have the binomials, every binomial has to show up once in the denominator. So x plus 2, we have to have an x plus 2. And then x plus 3 is also in one of them, so we have to have an x plus 3 in there. So now we're going to look at what this changes things to. So we have x squared minus 5 over x plus 3 times x plus 2 and times something plus 1 over x plus 2 times something. So to get from here to here, we don't have to do anything. We just multiplied by 1. To get from here to here, we have to multiply by x plus 3. So we'll have x plus 3 over x plus 3. So then whenever we go further with this, when we simplify, we get x squared minus 5 over, and I'm actually just going to write LCD, okay, because I'm tired of rewriting this over and over. And then on the right side, we have plus x plus 3, because 1 times x plus 3 is just x plus 3. Then we can combine like terms on the top to get x squared plus x minus 2 over the LCD. Then we can factor the top to get x plus 2 times x minus 1. And here I'm going to write our LCD back in because we're factored and we're ready to see if anything gets canceled. So we can see that the x plus 2's will cancel and we get x minus 1 over x plus 3. All right, number 13. I've got this one and one more for you. So first we factor the denominators. Well, these are both factored and they are both binomials. And when you can't find, when you're not sure about what the LCD is, you can always just multiply them together. And so we are going to say that our LCD is w plus 1 times w minus 7. So 5 over w plus 1 times something plus 8 over w minus 7 times something. This is going to be, we had to multiply this one by w minus 7, so we have to do it top and bottom. And we had to multiply this one by w plus 1, so we'll do it top and bottom. So this gives us 5w minus 35 over our LCD plus 8w plus 8 over our LCD. Since the denominators are the same, we can just add straight across. So 5w minus 35 plus 8w plus 8 all over the LCD. Then we combine like terms to get 13w minus 27 over the LCD. Now, 13W minus 27 cannot be factored, so we're going to rewrite this with the LCD actually filled in. And if you look, nothing can be canceled here. So this is just our final answer. And here is our last example. So we're going to factor the denominators. This guy can be rewritten as 4 times p minus 5. And this guy can be rewritten as p minus 5 times p minus 3. All right, so our least common denominator, we have coefficient. We only have one coefficient, and it's a 4, so that has to go in the LCD. We don't have any variables by themselves, so now we look at binomials. So we have a p minus 5 here and a p minus 5 here. As long as it only shows up once in either denominator, you only have to put it in there once. The only time you have to list it twice is if it shows up twice in the same fraction. But it's not the same fraction, so we're good. All right, and then we have to include a p minus 3 as well. All right, so we have 2 over 4 times p minus 5 plus p minus 6 over p minus 5 times p minus 3. Oh, I forgot to put our times something in here. Okay, so to get from 4p minus 5 to our LCD, we had to multiply by p minus 3. And then to turn our second denominator into our LCD, we had to multiply by 4. So now we have 2 times p times, 2p minus 6. There we go. Over our LCD plus distribute the 4p minus 24 over our LCD. And we're going to get 2p plus 4p is 6p, and negative 6 plus negative 24 is negative 30, all over our LCD. And then we can factor a 6 out of the numerator. And since it's factored, I'm going to rewrite our LCD down here. 4 times p minus 5 times p minus 3. And our p minus 5s will cancel. 6 and 4 are both divisible by 2, so I'm going to change the 6 to a 3 and the 4 to a 2. So now we have 3 over 2 times p minus 3. And that's your final answer. Thank you guys for watching and listening, and have a great day.